digs into some fascinating sources, and hopefully maps out a clear path so you feel truly well informed. And today, we're heading into some seriously mind-bending territory. We're exploring what might happen when you take a specific kind of elegant geometric idea, something called circle inversion, and apply it to the universe's biggest puzzles. Now, you actually came to us with these incredibly ambitious what-if questions. You're asking, what happens if we apply circle inversion geometric equations to, like, string theory equations or Einstein's equations? What could we find? And then, you took it even further, wondering, what if we apply the same geometric thinking to consciousness or memories or even the Big Bang? But you also, quite rightly, added a note of caution. You mentioned, being wary of outlandish claims, wanting to ensure this stays grounded in actual science and math, real existing stuff, not altered realities or anything like that. And honestly, you're absolutely right to be cautious, but that's exactly why this is so interesting. We're looking at technically possible applications of established ideas, not making stuff up, staying testable.
Exactly. And what's really compelling here, I think, is how this one mathematical concept, circle inversion, might offer a new perspective, maybe even a unifying framework for fields that seem totally separate. It's not about, magic. It's about looking for underlying symmetries, transformations that might just be built into reality itself. We're hunting for deeper structural connections.
Okay, let's break this down then. Before we start applying it everywhere, what is circle inversion? Can you give us a clear, sort of accessible handle on it?
Yeah, absolutely. So at its heart, circle inversion is a geometric transformation. It's a specific way of mapping points. Imagine you draw a circle on a piece of paper that's your inversion circle. What inversion does is it takes every point inside that circle and maps it to a corresponding point outside. And conversely, every point outside gets mapped inside. The circle itself stays put.
Okay, so it flips inside and outside, like turning a sock inside out.
That's a good analogy, yeah. Or maybe like creating a photographic negative. The entire picture changes. Its configuration is completely different, but the essential information, the relationships between points, that's preserved. And crucially, it preserves angles. If two lines cross at a certain angle before the inversion, they cross at the exact same angle after. It's called being conformal.
Angle preserving.
Okay.
So even if shapes get distorted, stretched, or shrunk, the angles where lines meet stay the same?
Precisely. Think of stretching a rubber sheet with a grid on it. The squares might become weird shapes, but the corners will still be 90-degree angles where the lines meet. That's the conformal part.
And that's why it preserves information, because those fundamental geometric relationships hold true.
Exactly. It ensures this kind of informational coherence. You're looking at the same core information, just from a radically different flipped perspective without actually losing the details. That's why it's potentially so powerful.
Right, okay. That makes sense. So now for the big leap. How does this mathematical flip, this angle-preserving transformation, connect to fundamental physics? You mentioned Einstein's equations, string theory. How does it bridge that gap?
Well, it's not just a mathematical curiosity in physics, it's actually a tool. One key area is bridging scales. Physics deals with the incredibly tiny, the quantum, and the unimaginably vast, the cosmic. Inversion provides something we sometimes call a UV-IR exchange heuristic.
UV-IR, ultraviolet infrared, like light. What does that mean here?
Sorry, physics jargon. UV refers to high energy, short distances, the ultraviolet end of the spectrum. IR refers to low energy, long distances, infrared. So UV-IR exchange means inversion literally swaps small distances for large ones and vice versa.
Oh, okay. So it connects the micro and the macro scales mathematically?
Exactly. It helps us understand how theories behave as we zoom in or out, which is crucial for things like renormalization group flows, how physical laws appear to change with scale. And it's sort of fundamental to the idea of holography, too. Now, in certain parts of physics, what we call conformally invariant sectors, inversion isn't just a tool, it's a genuine symmetry of the system.
Okay, conformally invariant sectors, like specific situations where the physics doesn't care about the scale. Can you give an example?
Sure. Think about Maxwell's equations for light in 4 dimensions. They're conformally invariant. Or certain more theoretical ideas like Weyl-squared gravity, and importantly, certain aspects of string theory. In these specific cases, if you have one valid solution, applying inversion gives you another valid solution. It's like a mathematical factory for generating new, valid physical scenarios. It really constrains how things can behave.
So it helps predict or map out possibilities within those specific theories.
Yes, precisely. It locks down relationships between different scales.
But what about general relativity? Einstein's theory isn't conformally invariant, right? Gravity definitely cares about scale.
That's right. GR isn't conformal in the same way. But inversion is still incredibly useful, more like a surgical tool, particularly when we analyze the universe using something called conformal time, which sort of factors out the overall expansion inversion, helps us understand the structure of light cones, how information propagates, and especially behavior at infinity, meaning very far away or very early late times.
So it helps analyze the edges,
Yeah.
like the Big Bang or the far future.
Exactly. It helps us manage things like conserved quantities, gravitational wave memory effects, how things scatter. It provides a way to map these infinite boundaries onto a finite space where we can analyze them more easily. It's like bringing the edge of the universe or the moment of the Big Bang right onto our theoretical workbench.
This sounds potentially huge. I mean, you hear physicists like Michio Kaku talking about how string theory equations are just incredibly complex, maybe too complex to solve directly. And Neil deGrasse Tyson points out things like black hole mergers or early galaxies seen by JWST that just don't fit our current models easily. They force us to rethink. So could inversion be a key? Could this geometric perspective offer a way to simplify those equations or provide a new structure to understand these anomalies?
That's precisely the hope. And the motivation behind frameworks like PSUMOT, the psychedelic superfluid universal morphonic oceanic wave theory you mentioned, the idea is that maybe the complexity isn't just in the equations, but in our perspective. Inversion, by making these UVI arcos, these connections between small and large scales explicit, might reveal hidden simplicities or dualities. It might make parts of these theories solvable, or show how phenomena like those early black holes are natural consequences of an underlying, perhaps almost conformal structure we haven't fully appreciated. Maybe the universe is more like a superfluid than we thought.
Okay, that's a fascinating possibility. But if we take this seriously, it needs to make predictions, right? Things we can actually go out and look for. What are some concrete, testable predictions for cosmology coming out of this inversion idea?
Absolutely. Testability is key. There are several predictions, some outlined in what's called the Bang playbook. One is void halo mirroring.
Void halo mirroring. Okay, what's that?
So you take a large cosmic void, one of those giant empty regions in the universe,
Yeah.
and you mathematically center an inversion on it. The geometry suggests this should approximately swap the properties of the expanding void with those of a collapsing galaxy halo, an overdense region.
Swap them. How?
In terms of their gravitational lensing signal, the prediction is if you measure the weak lensing shear, how gravity subtly distorts background light around many voids and average it, and then do the same for many galaxy halos, the two signals should map onto each other after you apply the inversion transformation and rescale appropriately.
So you'd expect a specific mathematical relationship between the lensing patterns of voids and halos.
Exactly. And any deviation from that predicted relationship tells you exactly how much the universe's large-scale flow deviates from being perfectly conformal. It's a quantitative test.
Interesting. What else?
Second, CMB anomalies, or bang hair. We see some strange large-scale patterns, anomalies in the cosmic microwave background radiation, the Big Bang's afterglow, that don't perfectly fit the standard model. The prediction is that if these anomalies truly originate from the very early universe, from the initial boundary conditions, then when you map the CMB sky using inversion, these large-scale anomalies should focus down into localized features with predictable sizes in the inverted map.
So it would act like a lens, focusing ancient signals.
Sort of, yeah. It gives
Yeah.
us a surgical map to potentially distinguish genuine early universe signals from foreground structures that might just be mimicking them.
Okay. And you mentioned PSUO earlier, the superfluid idea. Does that have specific tests?
It does. The PSUMO superfluid test. If the universe on large scales behaves hydrodynamically like an almost conformal superfluid, then inversion demands specific mathematical relationships between different statistical measures of how matter is clustered. For instance, the shape of the bispectrum, a measure of three-point correlations in regions dominated by voids, must match the bispectrum shape in regions dominated by halos after you apply the inversion map.
So a direct statistical comparison between empty regions and clustered regions linked by inversion.
Precisely. And if that specific match isn't found in the data from galaxy surveys, then that aspect of the PSCMO model is falsified. It's a clear pass-fail, as you said, not a vibe.
Right. Clear predictions, clear potential failures. That's science. Okay, now, let's take that really bold leap you propose from galaxies and the Big Bang to consciousness. How can a geometric transformation possibly model something as subjective, as internal, as consciousness or memory?
It sounds like a huge leap, I know. But the idea is to model the structure of conscious states and the transitions between them. Geometric inversion seems to map surprisingly well onto shifts between what we might call our normal, everyday embodied local consciousness and states often described as non-local.
Non-local consciousness, like in altered states or mystical experiences.
Exactly. Things people report during deep meditation or with psychedelics or even near-death experiences. Concepts like the mirror world, which figures like Terence McKenna spoke about poetically, can potentially be understood geometrically. Inversion provides a rigorous way to think about it. The mirror world is the mathematically inverted configuration of the normal state. It takes it from metaphor to a potential geometric structure.
Okay. But is there any biological evidence that something like this happens? In the brain?
Well, this is where it gets really intriguing. Neuroimaging, like fMRI and EEG, during intense DMT states shows something remarkable, a profound decoupling of brain networks. The usual hierarchy breaks down. Different brain regions connect in unusual ways. This network desegregation seems to correspond quite directly to the geometric idea of flipping inside and outside regions. The boundaries dissolve, allowing for new integrations, new conscious experiences.
The brain's functional structure literally reorganizes in a way that mirrors the geometry.
That's the hypothesis.
Yeah.
And there's more. We also see changes in brain wave direction. Normally, information flows backwards, supporting predictive processing, our brain predicting the world. Under DMT, this can reverse with more forward-traveling waves, like raw sensory input taking over.
Like the brain's antenna retunes.
Exactly. It's like it inverts its usual processing direction, perhaps tuning into a different kind of information field, or accessing that inverted reality. It's a measurable neurological shift that parallels the geometric inversion.
And what about information preservation? You stress that for the physics side. Does consciousness lose information in these states? Like in dreams, things seem distorted.
That's where the conformal angle-preserving property is key again. The idea is that even in profoundly altered states like dreams, the core informational structure, the relationships, the emotional content is preserved, even if the surface details seem bizarre. It allows for a continuity of self, a way to navigate these state changes. And the involution property, the fact that inverting twice gets you back to the start, suggests these transitions are fundamentally reversible.
So the mirror world, the unconscious, isn't just chaos. It holds the information to reconstruct the original state.
That's the implication. Complete, perfectly preserved information mapped between these different states of being.
And the DMT decoupling protocol you mentioned fits into this how?
It frames these DMT states as maybe a kind of practice run, a rehearsal for the death transition. A way to consciously experience this geometric reorganization, potentially accessing deeper layers of the unconscious, this mirror world. And this isn't just abstract geometry. It connects to work by people like Gustav Brunner on inversive geometry and models like the projective consciousness model. Plus, the PSU framework tries to ground it in quantum biology, biophotons, microtubules, quantum effects, and nerve insulation, suggesting a physical basis for this geometric matrix of consciousness.
It sounds like it could also explain why these experiences often feel both universal and personal, like McKenna's jeweled basketballs versus Ezekiel's eyed wheels. Same deep structure, different personal overlay.
Precisely. That's the idea of observer shaping. When the brain's usual filters are offline, your personal information wave, your memories, beliefs, culture interacts with a deeper, perhaps universal field of potential. This interaction co-creates the specific content of the experience. So you get these underlying archetypal similarities, but expressed through your unique personal and cultural lens.
Okay, connecting this back. Dr. Sam Parnia's research on near-death experiences. He reports people having awareness, verifiable perceptions, even when brain activity is minimal or seemingly absent, and the life review phenomenon.
Yes, Parnia's work is highly relevant here. The findings awareness during cardiac arrest, hyperreal perceptions, the life review, where people sometimes relive events from others' perspectives, these align remarkably well with the inversion model.
How so?
Well, the geometric framework offers a potential mechanism. It suggests how consciousness, perhaps as a field the brain tunes into, could preserve information even if the receiver, the brain, is offline. The angle preservation ensures information coherence. The life review, especially seeing things from other viewpoints, could reflect accessing a broader information field facilitated by this inverted state. It supports the idea of the brain as more of a transceiver for consciousness than its sole generator, and DMT might chemically trigger a similar process.
Wow, okay. That's a lot to take in.
But circling back to your original caution, avoiding the wackos, keeping it scientific, with ideas this profound, stretching from cosmology to consciousness, how do we maintain rigor? What are the guardrails?
Absolutely crucial. This has to be about recovery math, not mysticism, as the saying goes. It means hard falsifiers. clear tests, for instance, those angle invariants I mentioned. If we measure angles in brain network activity, say during waking versus DMT states, the distributions must show the predicted preservation, statistically beating random chance by a pre-agreed amount using specific tests like a KS test. If they don't, the hypothesis is weakened.
So clear statistical hurdles.
Yes, and information gain. If we claim inversion helps recover or access information, like in memory or NDEs, then applying formal information recovery techniques like a PETS map must demonstrably increase the measurable information compared to simpler methods. If it doesn't add information, the claim fails.
No information gain, no dice. Exactly. Plus, rigorous negative controls. Run the whole analysis on scrambled data, or data where you know the effect shouldn't exist, or using transformations that aren't conformal. If you still see the effect, it was an artifact, not real. And absolutely vital, pre-registration. Before you even look at the critical data, you write down exactly what you're testing, how you'll test it, and what counts as success or failure. One page, clear criteria, no moving the goalposts later.
Define the rules before playing the game.
Precisely. It prevents wishful thinking. We have to be honest about limitations, too. If PETS recovery fails, the analogy breaks. If angle preservation fails statistically, the dream-waking inversion claim is shaky. And finally, ethically, when you're pushing into territory that can really challenge someone's view of reality, you need professionals involved. Psychologists, therapists, people who can help manage potential ontological shock or instability. This isn't just abstract math, it touches deep parts of experience.
Right. It's not about belief. It's about rigorous testing, clear failure points. Rigor, not incense, as you put it. So what we've really explored today is the, frankly, astonishing potential reach of geometric inversion. It's a mathematical concept that seems to offer not just a new way to look at old data, but a way to generate concrete, testable, falsifiable predictions across physics, cosmology, and maybe even consciousness itself. From black hole information puzzles to the structure of the early universe to perhaps modeling the very shifts in our own awareness. It's more than theory. It feels like a call for new kinds of experiments, a genuinely fresh perspective on the universe, both outside us and inside.
And if you connect all those dots, it really does suggest a profound underlying unity, doesn't it? The thought that the same geometric principles could be at play in the Big Bang and in the architecture of our subjective experience. It's quite something. It challenges that fragmented view of reality we often have. Maybe it's all one deeply interwoven, dynamic, geometrically coherent system. Which, I suppose, leaves a question for you, our listener. If reality is this kind of geometrically structured, information-preserving tapestry, what might that imply about meaning, about memory, about our own place within that intricate pattern?
Something to think about. Keep diving deep, keep asking those what-is questions. That's where the really interesting discoveries often begin.